Welcome to solverfy.
We are asked to find the coefficient of x to the 10 in the power series of each given function. In part A, the function we're given is 1 plus x to the 5th plus x to the 10th plus x to the 15th, and so on, cubed. We have that this is the same as, by a prior theorem, 1 over 1 minus x to the 5th cubed and this is equal to 1 over 1 minus x to the 5th cubed and from a table in the book, we have that this is going to be equal to the sum from k equals 0 to infinity of n plus k minus 1 k times, and then x to the 5th to the k, and the n is replaced by a 3, so to find the coefficient of x to the 10, we have that, first of all, this is equal to the sum from k equals 0 to infinity of 3 plus k minus 1 choose k x to the 5k, and we have that we get x to the 10th when k is equal to 2, and then the coefficient is going to be 3 plus 2 minus 1 choose 2, which is equal to 3 plus 1, which is 4, choose 2, and this is equal to 4 factorial over 2 factorial squared, which gives us 4 factorial over 4, which is simply 3 factorial or 6. In part B, we're given the function x cubed plus x to the 4th plus x to the 5th plus x to the 6th, and so on, cubed. We can rewrite this as x cubed times 1 plus x squared plus x cubed, and so on, all cubed. This is equal to x cubed cubed is x to the 9th times, and we have that this reduces to 1 over 1 minus x cubed, and this is going to be equal to x to the 9th over 1 minus x cubed, and we have from the table in the book that this is equal to x to the 9th times the sum from k equals 0 to infinity of, and this is going to be 3 plus k minus 1, choose k, and x to the k, which is equal to the sum from k equals 0 to infinity of 3 minus 1 is 2 plus k, choose k, times x to the k plus 9. And so to find the coefficient of x to the 10th, we want k to be equal to 1. And so we obtain that coefficient of x to the 10th, a10, is equal to 2 plus 1, choose 1, which is 3, choose 1, which is going to be 3. In part C, we are given the function x to the 4th plus x to the 5th plus x to the 6th. Times x cubed plus x to the 4th plus x to the 5th plus x to the 6th plus x to the 7th. Times 1 plus x squared plus x cubed, and so on. And to simplify this problem, first, rewrite this as x to the 4th times x plus, or not x, but 1 plus x squared. And then we can also factor out an x cubed here, times 1 plus x squared plus x cubed plus x to the 4th. And then by a theorem, we have that this is equal to 1 over 1 minus x This simplifies to x to the 7th times excuse me, this is going to be 1 minus x cubed over 1 minus x times 1 minus x to the 5th over 1 minus x times 1 over 1 minus x. And this reduces to x to the 7th times 1 minus x cubed times 1 minus x to the 5th times 1 over 1 minus x cubed. And so we get x to the 7th times 1 minus x to the 5th minus x cubed plus x to the 15th times, and from a table in the book, this is the sum from k equals 0 to infinity of 3 plus k minus 1, choose k, times x to the k, this is equal to x to the 7th minus x to the 10th minus x to the 7 times 5 is 35th plus x to the, well, not 5, but 7 plus 5 is 12 plus x to the 15 plus 7 is 22 times the sum from k equals 0 to infinity of 3 plus k minus 1 is going to be 2 plus k. Choose k, x to the k. We have that this is equal to the sum from k equals 0 to infinity of 2 plus k, choose k, x to the k plus 7 minus the sum from k equals 0 to infinity of 2 plus k, choose k, x to the k plus 10, and the rest of them don't really matter, so I'll just omit these. And we have that if we want the coefficient of x to the 10th, then in the first case, we'll want k to be equal to 3, and in the second sum, we'll want k to be equal to 0. And so we get the base of 10 is going to be equal to 2 plus 3, choose 3, minus 2 plus 0, choose 0. This is equal to 5, choose 3, minus 2, choose 0. This is going to be 5 factorial over 3 factorial times 2 factorial minus 2, choose 0 is 1. And so we get 5 factorial over 3 factorial is 5 times 4 over 2 factorial is going to be 5 times 2, which is 10 minus 1, or 9 as our answer. In part D, we're given the function x squared plus x to the 4th plus x to the 6th plus x to the 8th and so on. Times the function x cubed plus x squared plus x 6th, plus x to the 9th and so on. Times the function x to the 4th plus x to the 8th plus x to the 12th and so on. We have by a theorem, well, first before we use a theorem, we factor out an x squared to get 1 plus x squared plus x cubed, not x cubed, but in this case x to the 4th, and so on. Then factor out an x cubed here, and we get 1 plus x cubed plus x to the 6th, and so on. And then factor out an x to the 4th, and get 1 plus x to the 4th plus x to the 8th, and so on. And we have by a theorem that this reduces to, this is x squared over, over 1 minus x squared times x cubed over 1 minus x cubed times x to the 4th over 1 minus x to the 4th. And this is equal to, factoring out, we get x squared times x cubed plus times x to the 4th. This is 2 plus 3 is 5 plus 4 is 9 times and here it's a little bit tricky. So to understand this, I'll rewrite this as x to the 9th times the sum from k equals 0 to infinity of x to the 2k times the sum from k equals 0 to infinity of x to the 3k times the sum from k equals 0 to infinity of x to the 4k. And we want to find the coefficient of x to the 10th. Well, we see that if k is going to be greater than or equal to 1 in the case of x to the 2k, and then x to the 9th plus x to the 2k is going to be greater than or equal to x to the 11th. So that's not going to be helpful. So we have to have that k is going to be equal to 0 here. Likewise, k has to be equal to 0 here, and k has to be equal to 0 here. But then we have that this is simply the coefficient of x to the 9th, and not the coefficient of x to the 10th. And so it follows that there is no factor x in any of the sums and therefore we can't have an x to the 10th, and so the coefficient for x to the 10th is simply 0. In part E, we're given the function 1 plus x squared plus x to the 4th plus x to the 6th plus x to the 8th. Times the function 1 plus x to the 4th plus x to the 8th plus x to the 12th. Times the function 1 plus x to the 6th plus x to the 12th plus x to the 18th. And to find the coefficient of x to the 10th, in this case, the simplest way may be just to directly calculate. So if we take 1 for the first term from the first part of the function, the first product, we have 1 times x to the 4th times x to the 6th equals x to the 10th. And we also have it's the only possibility if we choose 1 for the first. Now if we choose x squared, it's our first factor, then we have x squared times, if we choose 1, the second factor, then there's nothing we can choose in the third factor to give us x to the 10th. But if we choose x to the 4th, there's still nothing we can choose but x to the 8th. This gives us already x to the 10th, so times 1. This is x to the 10th. And what if we choose x to the 4th for the first factor? Then we have x to the 4th times, if we choose 1 for the second factor, then the third factor is going to have to be x to the 6th. And if we don't choose 1, we can't get the 10. So we have to choose 1 in this case. And if we choose x to the 6th for our first factor, then our second factor, if it's 1, we can't get x to the 10th. If it's x to the 4th, then we already have x to the 10th. And then we choose 1 for the last factor. And if we choose x to the 8th for our first factor, we choose 1 for our second factor, then we can't get to x to the 10th. And if we choose x to the 8th and any other factor from the second factor, we can't get to x to the 10th. And so these are all the ways to get to the x to the 10th, and we see that there's 4 of them, so it follows that our answer, A10, is 4. I forgot one important contribution, however. Suppose that instead of x to the 8th, we simply choose x to the 10th as our first factor. Then our second factor is going to be 1, the third factor is 1. And so we have that A10 is actually equal to 5.